discuss about chapter 12. In this we are going to discuss about loading the data into the fact table and the importance of date dimension table and lookup transformation, persistent cache and aggregator transformation. Already we have loaded the data into dimension dealership table, payment table, product table, customer table, promotion table, dimension employees table, and we need to load data into sales fact table. In the sales fact table, while we are loading the data into the sales fact table, we need the keys of the dimension tables. Now let us look at the requirements. Mapping should load data across into the fact table, and also while loading the data it should aggregate the data to the level of the fact sales primary keys. Now look at the requirement. From STG transaction table you need to load data into fact sales table, and in the fact sales table you have product key, customer ID, dealership key, payment key, promotion key and date key. These are the key fields, and you need to calculate units sold, discounted amount, revenue, cost. But if you look at the source, you have the product ID, customer ID, dealership ID, payment description, promotion ID and the transaction date. This is the data from STG transaction table, and we need to load data into the fact sales table. So before we go further down, let us look at the data in the STG transaction table. Select star from So the data is coming from this transaction table: product ID, customer ID, dealership ID, payment description, promotion ID and the transaction date, and this is the fields. Let us look at the data in the fact table. Now if you observe the table columns in the fact table, product key, customer key, dealership key, payment key, promotion key and date key. These are the surrogate keys of the fact table. Now corresponding to these keys, where are we going to get these keys from? Please observe the specification document: product key, dealership key, payment key, promotion key, date key. These are the keys in the target table in the fact table. But if you look at the data coming from my staging transaction table, it does not contain keys. It has product ID, customer ID, dealership ID, payment description, promotion ID, transaction date. This is actual data coming from my source systems, but while loading into the fact table, it has to contain the keys of the corresponding product ID, corresponding dealership ID, dealership key, payment description. For the corresponding payment description, I need the payment key. For promotion ID, I need the promotion key. For the transaction date, I want the corresponding date key. So where will I get from? The information about these are in their respective dimension tables. From those dimension tables, we need to take the product key. Let us look at the dimension table. Select star from dim from product. So for this corresponding, I am going to the staging table. For this corresponding product ID, we need to search in this product dimension table. Then corresponding key should be loaded into your fact table. The same way with the dealership key. If you look at, there is a dealership key called 25. So, but where is that corresponding dealership key exists? Surrogate key exists in. Select star from dim dealership table, which you have already loaded with your dimension tables in the previous mappings. So corresponding keys it needs to load the data into the fact sales table. So if you look at the requirement, these are the keys for this corresponding product ID. For this customer ID, it is direct. For dealership ID is coming from my source, that is my staging table. But when I load the data into my target table, I need the corresponding dealership key. Where will I get it? From the respective dimension tables. Same way for transaction date, I need the date key. So, where is the data? Select star from dim dates. So, for the corresponding date value, I need the corresponding date key. How did I load this data into this? If you have remembered the data warehouse concepts, to the time dimension table, we load data using PLSQL stored procedures. So, with PLSQL stored procedure, I have already loaded the data into my time dimension, that is dim dates table. So for the date which is coming from my transaction table, that is STG transaction, I will take the corresponding date key. So to take these values, corresponding values, related values, to get related values for the particular product ID, product key, custom dealership ID, I want the related this dealership key, payment description related payment key, promotion ID related promotion key, get related value. For that we use lookup transformation. The purpose of lookup transformation is to get related values or to check if the corresponding value exists or not. If you remember the mapping of 7th STG employees doing a lookup, we got a related salaries value. If you look at the SCD1, SCD2, we were trying to get is that corresponding record exists or not. For that purpose, we use the lookup. Here we want for that product ID a product key. So corresponding lookup ID, lookup table on this, we will do a lookup and get the records. Then as per my requirement, I need to aggregate the data to the levels of the fact sales primary keys. These are all the primary keys in my fact sales. So these are all not null and primary keys. So all are primary keys. On this, based on this, we need to do aggregation. So what is aggregation of data? So as of now, what we have understood is we have a source STG transaction table. On which we have to load the corresponding key values. So we will do lookups to get the corresponding values. These are all lookups, so that we will be able to look into it to get the corresponding values. Then, as per my ETL specification document, they want to do aggregation of data based on the fact sales table. What is aggregation? Let us assume. Now we have a sales aggregate table. I am giving a very small example, please understand it. I have a sales aggregate table, I have data. I want to aggregate on item description, month, year and state to get a sum of quantity into price. I want item description, month, year and state. On that I want to calculate sum of quantity and sum of quantity into price. The requirement is I have a sales aggregate table in which I want to find sum of quantity and sum of quantity into price. Based on what? On item description, month, year and state. So what will we do? To get sum of quantity into price, if you look at from a basic SQL perspective, what we are doing, we are aggregating the data. We are aggregating the data based on these columns. So what we do in SQL, we write a select statement like this. Select item description month year state, sum of quantity into price from sales AGG table, group by item description month year and state. Group by on item description month year and state. Look at the table on the top and the query, how many records it will return. I am not asking the whole values, I am just asking how many records it will return. Let me go to the table also. This is a table which I am showing in my slide. So if I write a query like this, select item description month year state, sum of quantity, comma, sum of quantity into price from sales aggregate based on item description. So you use group by clause. How many records it will return? It will return 4 records. It will return 4 records. How? Observe the data. Group by on item description shirt January 2005 AP, shirt January 2005 AP, shirt January 2005 AP, shirt February no, shirt January 2005 AP. So based on the same data columns, on the same column, same data, same record with the same combination. Aggregation is that same combination of records. Take it, sum of quantity and sum of quantity into price. So shirt January 2005 AP, 10,000. Shirt January 2005 AP. Shirt January 2005 AP. So there is no combination of shirt January 2005 AP. So how much it is? 10 plus 20, 30 plus 20, 50 plus 10, 60. 10 into 10,000, 10,000. 20 into 20,000, 40,000. 40 plus 10, 50. 20 into 10,000, 20,000. 50 plus 20, 70,000 plus 10,000, 80,000. Sum of quantity into price. Next combination, pant January 2005, pant January 2005 Tamil Nadu, pant January 2005 Tamil Nadu. So 3 records, 1, 2, 3, 30 plus 20, 50 plus 10, 60, 30 into 10,000, 30,000, 20 into 1,000, 20,000, 10 into 1,000, 10,000, 60,000. Then next combination, shirt February 2005 AP, 20, only 1 record, shirt February 2005 AP. Then the next combination, pant January 2005 AP, pant January 2005 AP, only 1 record, so 20,000. So this is how aggregation works. Grouping the same data, same record with same combination will be grouped, and sum of quantity into price. This is what is aggregation. So what he wants from this ETL specification document, as per the ETL specification document, he wants to aggregate the data based on the fact table, sales tables, primary keys. So he wants to aggregate on this and calculate units sold, discounted amount, revenue, cost to be loaded into this target table, that is the sales fact table. Per unit sold, sum of sales quantity, discounted amount, revenue, calculation, aggregation. Based on these keys, they want to aggregate it. So this is called as aggregation of data with a transformation called aggregate transformation to do aggregate functions. So it contains input port, output port, and a variable port, and a group by port. To do aggregation on any data, you need to do based on some common columns, that is item description, month, year, and state in our case. So to do group by, aggregated transformation provides you with a group by ports. And it supports only aggregate functions like sum of quantity into price, aggregate functions. For that you have a expression editor. In that you will write the formulas. It will support average, count, first, last, max, median, min, percentile, standard deviation, sum, variance, aggregate functions. It will support. So in aggregated transformation is used to aggregate the data. For that purpose, Informatica provides you with aggregated transformation. Now, let us take the example of the sales AGG table. I just want to find the aggregated values based on group by clause, item description, month, year, and state. So what we do in Informatica, I will define the source, I will drag it, I have a source qualifier, and I will have an expression transformation, best practice. Then I have aggregated transformation. In that I did a group by on item description, month, year, and state. Then calculation, sum of quantity into price. I created output ports only and I have written the formula. Then this is my target table. Now how Informatica works. When you execute this, Informatica extracts the complete data from the source and it will do row by row process. It will do row by row process. So what is this row by row process? That is the way Informatica functions. It will do row by row. So first record comes in out of expression transformation and goes into the aggregated transformation. Now aggregation, what is we do aggregation? We aggregate the data based on same combination record. But Informatica will perform row by row. So if a first record comes into the aggregator, how can it aggregate same combination of records? It cannot do it. So what we do? Informatica provides you with a cache for aggregator. So row by row, Informatica server processes the records, but when you have aggregated transformation, it will put the data into the aggregator cache. It will put the data into the aggregator cache. So at runtime, Informatica allocates memory space and puts the data into the aggregator lookup cache. First record comes in, data goes into the aggregator lookup cache. Then the second record is released from the source qualifier, goes into the expression transformation, goes into your aggregator lookup cache. Then the third record comes in, goes into your expression transformation, goes into your aggregator lookup cache. Fourth record comes in, goes into the expression transformation, goes into the aggregator lookup cache. Fifth record comes out of source qualifier, expression transformation, then input to the aggregator lookup cache. It will put the data in your cache. Then the next record, like this, it has put the data in the cache of aggregator. So row by row data comes into the aggregator cache. Now what does aggregator do? It will scan the cache based on the same combination of records and releases the calculated records like this. This data is in the aggregator lookup cache. First record, it will mark shared January 2005 AP. Internally, Informatica process this records like this. 3rd January 2005 AP, 3rd January 2005 AP. Next record it says pant, no, not the same combination. Shirt, February, not the same combination. Pant, January 2005, not the same combination. Then shirt, January 2005 AP is the same combination. Then it looks at the next record, not the same combination. So it will aggregate shirt, January 2005 AP, 10 plus 20 30 plus 20 50 plus 10 60, and it will calculate sum of quantity and sum of quantity into price, and it will release to the target table. Then goes back to the cash, marks the second record combination, pant, January 2005 Tamil Nadu, pant, and just marking it for your understanding. Internally it will mark, Informatica will mark the same combination of records in the cache by scanning. So pant, January 2005 Tamil Nadu, next record it will check, it is not, it is already marked, so it goes to this, then it will mark it, then goes to the third record, shirt, February 2005, not the same combination, pant, January 2005 Tamil Nadu, same combination. Pant, January 2005 AP, not the same combination, so pant 30 plus 20 plus 10 60 and multiplied by that thousands, 60,000. Then again it goes to scans the cache which is unmarked. So this is unmarked, it will mark it. Then goes and checks which are unmarked records, are they same combination. So shirt, February 2005 AP, there is only one combination. So it will scan and puts it into the scans the data and goes here. No combination of the same record. Then goes to the mark the unmarked record, scans the cache, it scans the cache and checks the record, so it loads the data into the target. So this is how aggregated transformation. This is the way aggregated transformation. It contains input port, output port, variable port and a group by port. We need to group by on that columns, on those records which we require. Which combination of columns you want, you group by on it. Then you will calculate aggregation functions. You will use aggregate functions in aggregated transformation. Then how Informatica works, when you use aggregated transformation, as Informatica server process row by row, when the data comes to the aggregated transformation, the first record, actually you have to aggregate based on the complete set of data, not on a single record. If the combination is single record combination, fine, but you need the complete set of data. So aggregated transformation allocates memory space to that transformation, puts the data into the aggregated lookup cache, scans the data, scans the cache. If it finds the same combination of records, then it sends out to the next transformation or to your target. So this is how it will work in aggregated transformation. So when you do this aggregated transformation, it has to do scans the cache row by row, finds the record and sends it out to the next transformation or to your next target. So now we will do the lab on our requirement. So what is our requirement? We have to calculate sum of quantity, sum of discount selling price based on the keys. So to get the data, corresponding data from this product key, dealership key, payment key, promotion key and date key, we need to do a lookup on the corresponding dimension tables. Then we have to calculate the aggregation. We'll define the source, we define the target, and we'll define the lookups. So let me go to the Informatica mapping now. So what is the first step we do? We define the source from database, that is your staging, because your table is in the staging database. So use the ODBC connection for staging. Get the STG underscore transactions, not the AGG table. Then you say OK. Then import from database to the warehouse designer. Get the fact sales table. That is your target to define it. Now mapping. Create M_14_ To do aggregation of data, M_14_ fact sales. Now we'll drag our source, that is STG transaction table. We'll drag our source, that is STG transaction table. Now, as per our requirement, what we need to extract the data from STG transaction table and load the data into fact sales table. But we need to find out the corresponding keys. So we'll do a lookup on the dimension tables. But best practice, transformation create expression. So I'll take all the columns from here and put it in the fact sales table. Now let us drag my target table. Let us drag the target table, and I want the corresponding product key for this corresponding product ID. So I do a lookup on dimension product table. I import from relational table, that is on TGT database, dimension product. Then what is the input for this? Is a product ID coming from my source expression transformation as per this mapping. I rename this as my input. I remove all the other columns which I don't require performance tuning. I want product ID to product ID, and I want the corresponding product key. So I specify the condition. Be careful here. It will show you the first column. The condition you need product ID to product ID input, not the product key. So one lookup. For customer ID, it is direct in my target table, so I don't need to use a dimension customer table. Now dealership ID, transformation create another lookup on dealership. Import from relational table, connect PIM dealership table. Then I'll put my dealership ID into this. I rename this as my input, and I remove the columns which I don't require. Condition, add dealership ID is equal to dealership ID input. Then transformation, create lookup on dimension payment. Port from relational, dimension payment. So here, be careful, it is payment description which is coming from my source. So I don't need payment ID, so I remove it. This is my input. I rename it for my better performance, better documentation, you can call it as. Condition, payment description is equal to payment description input. I'll take the payment key out. Then another transformation, create lookup on promotion dimension promotion table, import from relational table. This is dimension promotions. So what will be the input for this? This is the promotion ID. I'll rename this as my input. So I remove these columns which are not required. Condition. Be careful. After you do the mapping also, please check, open all the lookup transformations and check, have you given the conditions or not. Transformation, create lookup on dim dates, dimension dates table, import from relational. You say OK. Input to this is transaction date. I remove, it is condition is between the date value. Date value is equal to transaction date is the condition. I remove all the other columns which I don't require. I specify the condition. I say OK. So now I did the lookup on all the tables as per my requirement. Product key, dealership key, payment key, promotion key, date key, customer ID is directly coming from my STG table. Now what should we do? We need to aggregate the data. So transformation, create aggregator. Aggregator on fact for fact sales table. This is your aggregator transformation. What you need? Product key. Then what you need? Customer ID from here. Then dealership key. Then payment key. Promotion key. Then date key. So these are the keys. Now what are the columns I require from my expression transformation? I'll put holdback first because I need a holdback here after the date key and the rebate. Then I'll put selling price, unit cost, delivery charges, sale quantity, discount into my aggregated transformation. So this is your requirement to calculate sum of sales quantity, discount, sum of selling price, sum of unit cost, aggregation on these keys. So let us open our aggregated transformation. It contains ports, as I said before, input port, output port and a variable port and a group by port. On which columns you want to do group by, you enable them. For me it is product key, customer ID, dealership key, payment key, promotion key and the date key. Based on these columns, I want to do the group by, so I enable the group by ports. Then I calculate units sold, add column port called units sold, decimal, output port only, formula. Like in expression editor you write the formula, here you write the formula of sum of sales quantity, validate. Another discounted amount is this formula, decimal, output port only. This is the formula which is given in your retail specification document. You can take it from there, the formulas. I'll create another folder called revenue. This is the formula. Then another port called cost. Make it all decimal too, please. The combination of this is unit sales. Now, this is the way you write your formulas. Now you connect it. Customer ID to customer ID, dealership key, payment key, promotion key, holdback rebate. Then, unit sold, discounted amount, revenue, cost, and save your work. Please open your sheet and write down these things in your ETL specification document. STG transaction table, ODBC connection for STG, username STG password, STG underscore your ID, TGT, username password, TGT underscore your ID, and to import the lookup tables, it is your ODBC connection TGT, username TGT underscore your ID, password TGT underscore your ID. So these are the things you have to do to create this fact sales table mapping. So as we need corresponding values of product key, dealership key, payment key, promotion key, and date key, you have to do lookup on their corresponding tables to get those surrogate keys. And in the aggregator transformation, you have to create the group by clause on the keys of this, because those are the primary keys as per your specification document. Then you need to calculate the sum of all these and you connect to the target table. This is how you create the mapping. Then we go ahead and create the session. So aggregator transformation is used for aggregate functions to get based on the group by port. So it needs a cache, a memory space where it will put, this is the cache size, this is its index cache size. What are the group by ports on which you are going to indicate on that? It will create the index, puts the data into the cache. Based on your group by ports, the same combination of records, it will scan the cache and mark them so that to calculate your aggregate functions and send that record out to the next transformation or to the next target table. This is the functionality of aggregator transformation. Now we are going to create the session for this particular mapping. So you have so many lookup transformation. For this you have to give the lookup connection. So let me go ahead and create the session for this. S underscore M underscore 14 underscore fact sales. Double click. Mapping. Source is your stage. Target is your TGT. Change bulk to normal. Then you have the lookup tables on which you are doing the lookup. So you specify the connection for each lookup. You should not forget it. You have to specify the connection for each lookup transformation. So I am giving to the connection for all the lookups. So at runtime, when you execute this session, all the data from the corresponding lookups will be in their respective lookup cache. Row by row informatica process, first record comes in, scans the cache for all the lookups and gives you the records. And in aggregator, it will put the data in the cache. And after it putting the data in the cache, based on your group by ports, it will scan the cache for same combination of records it will take and do your aggregate functions and send that record out to the next transformation or to the target table. So I have created the connections for all the lookup transformation and the source connections and the target connections. Then in the workflow designer, I'll go and create the workflow. WF S underscore M underscore 14 underscore fact sales Before we load, let me check the data in my target table. Does it have or not? No. So start workflow. So I have executed it. The workflow. Let me go and check the data in my target table. So for the corresponding product key, customer ID, dealership keys, payment keys, promotion keys, and the date key, then it has calculated the aggregated data. So go ahead and open your sheet to write this combination for your session log file, sessions and the workflow, stg underscore your ID, tgt underscore your ID, then target connection, and for lookup connections, tgt, and the workflow name. So this is how you create the session and the workflow, and you execute it. Aggregation of data. To do aggregation of data, now we are going to discuss about the performance tuning of aggregated transformation. As discussed, aggregated transformations as cache. We will do group by on the complete set of data, and based on the group by ports, aggregated transformation will identify same combination of records in the cache at runtime and marks it, and whichever is the same group condition, based on that calculation of aggregation, sum of quantity or sum of quantity to price, whatever the aggregation values, it will do aggregate it, do the calculation, and send to the next transformation or to the next target. So basically, the aggregated transformation needs complete set of data. It needs a complete set of data. So assume that, just visualize that there are 2 lakhs records coming from my source table, and I put it in the cache of aggregator, 2 lakh records cache, and group by on a combination which is 10,000 combination. Different combinations are there in that 2 lakhs records. Means basically 10,000 records will be the output of it. But the challenge is aggregated transformation takes every record, scans the cache row by row, as aggregated transformation puts the data, informatica, while in processing the data, it will put the data into the aggregator lookup cache. Now assume that there are 2 lakh records and a different 10,000 records combination. Like the output of this is 4 records, 4 combinations. Like that, assume that there are 2 lakh records, and for each record combination, what informatica does, it will scan the cache. Same combination, shared January 2005, shared January 2005, PAN, not the same combination, then goes to the next record, then PAN, not the same combination, goes to shared February, January, not the same combination, then PAN, January, PAN, different combination, then shared January 2005, AP, same combination. So it will scan the cache, marks the record, then it sends the record out, then goes back. Whichever is the first unmarked record, it will take it, then goes to the unmarked records. Is it the same record or not? PAN January 2005 Tamil Nadu, yes. Shared, no. PAN January 2005 Tamil Nadu, yes. Then goes to the last record. What it is doing, it is scanning the cache. Based on each combination, it will scan the cache. Then it will send you the record out. So assume you have 2 lakh records, and each and every record will be scanned For each combination, it will scan the whole cache. So then it will send you the output. Now, it is a performance issue because for each combination, it will scan 2 lakh records. Total scanning. So if you have 2 lakh records and you have 10,000 records of different combinations, like here in this case you have 4 combinations. So 10,000 records means 10,000 combinations, 10,000 combinations. Each combination, it will scan the whole cache. For each combination, it will scan the whole cache. That will decrease the performance of your mapping when you have a aggregated transformation. Is a bottleneck in your mapping. But you cannot go away with it because whenever you want to aggregate the data, you have to use the aggregated transformation. So what we will do? What can be done? The problem statement, the challenge statement is aggregated transformation as a cache. Row by row, data comes into the cache. After complete data comes in, then based on the group by ports, for each combination, it will scan the cache. That is, scan the complete records. Whichever is marked, scans the cache and marks it. Second combination, it will go there. There is unmarked records, it will scan not the marked records. But still there is a performance. Every time it has to scan the whole cache. How to overcome this? One is very clear for us. Informatica server, when it processes the data, it will do row by row. That is very clear. So row by row data comes into the cache of aggregator, because aggregator needs complete set of data. Not complete set of data, not aggregator needs. Aggregator function works like that. Group by function works like that. So you cannot go away with it. That row by row data comes into the cache. That is also a slow process, but we cannot do anything. Somehow we have to reduce the time to scan the cache. That is, for every combination that is based on your group by, it should not scan the whole aggregator cache. It should not scan the whole aggregator cache. Because for every combination it is going up and down. Rather than we have to reduce the time that it does not go and scan the cache completely. For every record, all the whole scan of the cache, even the last record it may not have the same combination, but still it will scan the whole cache. So what we should do? Solution for this is somehow we get the data into the cache based on order by group by ports. Get the data into the aggregator cache, order by based on the group by ports. So if you get the data in order by based on the group by ports, same records, but you should order by and get the records. Then how it works? Assume that this data is in the cache. This data is in the cache. What will happen? Order by based on item description, month, year and state. You get the data. So PAN January 2005 AP, PAN January 2005 Tamil Nadu. It will do order by. I'll show you in the mapping. Somehow you ensure that this data comes in order by fashion before coming into the aggregated transformation. Aggregated transformation should not do order by. Before coming into the aggregated transformation, somehow you should ensure that data comes in order by fashion based on the group by ports. So I write it in a source qualifier, SQL override, select from these tables where group by on these ports, order by on item description, month, year and state. If I do order by on item description, month, year and state, this is the data which is extracted from the source table. Please observe, it is order by based on item description, month, year and state. So it gets the data from the source table in order by fashion. Now what happens? Row by row data comes into the aggregator cache in this format. Aggregator transformation will not do order by. Please write it down very specifically. Aggregator transformation will not do order by. You have to ensure that the data comes into the aggregator transformation in a order by fashion. Now when row by row data comes in and it will put the data in the aggregator cache like this, then how does the grouping works? First record it will mark pant January 2005 AP goes to the next record. Pant January 2005 Tamil Nadu, not the same record. So it will stop the scan here for this combination. It will stop the scan here itself. It will not go down because data is coming in a order by based on group by ports. To ensure that data is coming in order by based on group by ports into the aggregator transformation. Aggregator transformation will not do order by. So pant January 2005 AP, no combination of the same record. That means because you did order by, definitely there won't be the same combination of record down this records because you did order by. So what happens? We take this, sends out, goes to the next combination, pant January 2005 Tamil Nadu, pant January 2005 Tamil Nadu, pant January 2005 Tamil Nadu, sure. So because you made it order by, it should be, this combination should be in this set only, it cannot be down the line. As soon as the combination changes, business of informatica knows that there is no record with this combination down the line, so it will group it and send it across. Then next record it will take, marks it, the next unmarked record, shared February 2005 goes here, shared January 2005 AP, not the same combination. So it will stop the scan here and sends the data out. Then it will mark this record, shared January 2005 AP, shared January 2005 AP, shared January 2005 AP, shared January 2005 AP. So then there is no record, so it sends the record out. So this is how you can reduce the time of your scanning of the cache based on your group by ports. But you have to ensure that the data coming into this aggregator transformation is order by already. It will not do order by, please. You have to ensure data coming into the aggregator transformation in an order by fashion based on the group by ports. To do order by, one way is do order by in the source qualifier itself. Other way is Informatica provides you with a transformation called sorter transformation. The purpose of this sorter transformation is to order by on ascending or descending order. You can do sorting on a flat files, you can do sort data before an aggregator or anywhere in the mapping. It contains input port, output port and a key port. This is where you indicate what are the keys, on which columns you want to do order by, and the direction, ascending or descending. So you have to ensure data coming into the aggregated transformation. For that, you have to ensure that the data comes in an order by based on the group by ports. So sorted transformation works like order by. You can do order by at the database level. That is, if you want to do order by, then you have to use order by in the source qualified transformation, or in the Informatica provides you with this transformation called the sorter. It has input port, output port, and a key which indicates ascending or descending, or which ports on which you want to do it, then the direction, ascending or descending order. So I will create this mapping. Already I have created the fact cells. Now same mapping I will use it, but you can copy and paste it. I will create the same mapping with a different name. For that, in mapping in the designer you can copy paste, but same session will not work. You have to create a new session for the mapping. So to do use sorter transformation, I am showing you how you can work it. I copy this, then edit, paste. Then it will ask to resolve the rename. Yes, I will rename it as, just to indicate it is a sorter. Next, finish. So I created a new mapping. Simple, select the go to that folder. Folder should be the same. Go to that mapping, select it, and you say edit and copy. Then you paste it. Then it will ask the name. Rename it. So this is your mapping. Yesterday's fact sales mapping. Now let us use sorter transformation. Remove all these columns. Transformation, create, sorter. Syntax for sorter is SOR. So first column, product key. Second column, customer ID. Third column, get ship. Fourth column, payment key. Fifth column, promotion. Column, date key. Then what more we need? Expression transformation. Sorter. Hold back. Date. Selling price, unit cost, delivery cost. I'll connect all this to my create a transformation. Now, this is your sorter, ports, properties. It will also have a cache. So on which column we want to do order by? Product key, customer ID, dealership key, promotion key, payment key, promotion key, and the date key. So you did order by. This is the key port on which column you want to order by. Ascending order. Properties. This also needs a cache, because when you want to do order by, you need the complete set of data. First column, first record may be the first record, or the last record, we don't know, or the last record may be the first record. When you do order by, so it will put all the data into the cache of your sorted transformation. Then it will scan the cache to do the order by. Only order by it will do, not the combination. And distinct, you can use if you have multiple values, the same combination, then you can say distinct. Then what happens? Just visualize, data comes into the aggregator sorted transformation, data is sorted before it comes into the aggregator transformation. Then into the aggregator cache, data comes in. Aggregator has a cache, data cache size, and index cache size. It will put the data in the cache. but the discussion we had that it scans the cache somehow. How does it know that data is coming in order by fashion? If it knows that order by fashion, if it is coming in, then you are saying that it should not scan the cache down the line if there is no combination of the same record. But how does aggregator transformation knows that data is coming in order by fashion? We have to indicate data is coming in order by fashion. We have to indicate in our mapping in the aggregator transformation in the properties sorted input. Sorted input means you are indicating to the aggregator transformation that data is coming in a sorted fashion. If checked, observe here, if checked, input to the transformation is assumed to be already sorted by the group by ports. Already sorted by the group by ports. If checked, input to the transformation is to be already sorted by the group by ports. So, you have to ensure, if you have made the order by based on the group by ports, that you are ensuring the data is coming into the aggregator in an order by based on the group by ports. But you have to indicate. If you do not indicate this, then aggregator transformation does not know that it is coming in order by fashion. So, we have to enable this sorted input property. But if you enable this, you have to definitely data should come in a order by based on the group by ports. See the message, if checked, input to the transformation is assumed to be already sorted by the group by ports. Assumed, it assumes that data is coming into my aggregator transformation cache in a order by fashion. So this is how you do the performance tuning of aggregator transformation. Under your user ID password in the target database, you need to go and create a stored procedure. Under your database of your TGT database, you need to create a stored procedure. This is written in the ETL specification document we have provided you. Under the TGT database, that is your target database, TGT underscore URID, and the database string is TGT. So, go and create this stored procedure, create or replace procedure, vendors underscore target underscore prop is begin delete from vendors underscore target underscore SP and commit and end. To create this under your database, we need it in the next chapter where we will use stored procedure transformation. So please go ahead and create this stored procedure in your TGT database. Aggregation.